Fiberglass is used in a multitude of ways. Everything from truck bodies to boats to aircraft, canoes, surfboards, tanks, and wind turbines are made with fiberglass. The finished fiberglass product is made from two basic components: resin and fiber reinforcement. First is a liquid resin which hardens to a rigid but brittle solid. The second is the fiber reinforcement that is placed in the liquid resin before it hardens. This reinforcement gives the cured resin its tremendous strength. Tap Plastics has a wide selection of fabric reinforcements. This video segment will explain the different types of fabric reinforcement and how to select the one that is right for you. Fiber reinforcement comes in several basic forms. The first is cloth, which comes in widths ranging from 1 inch to 50 inches. The word cloth accurately describes its woven appearance. Mat is identified by strands going every which way. Roving has large bundles of strands in a very coarse weave. And Nitex, which is a combination of short strand mat and long strand roving. When selecting a fiber reinforcement, there are 4 characteristics to consider. All of these are critical and are not presented in the order of importance. They are weight, strand direction, weave, and fiber composition. Let's look at these 4 in detail. The first is weight. The amount of reinforcement in a fiberglass product determines its strength. The more reinforcement, the more strength. Obviously, this fabric will not be as strong as this fabric because it has less material. In order to compare reinforcements, they are measured by their weight in ounces per square yard. This fabric is called a 3.75 ounce cloth because a square yard of it weighs just 3.75 ounces, whereas this fabric, called woven roving, weighs 18 ounces per yard, or 1 pound 2 ounces as you see on the scale. Generally speaking, the heavier the fabric, the greater the strength. By the way, fabric should never be folded like this. Folding can damage the fabric. It should be rolled onto a tube, avoiding wrinkles. The builder must decide how much reinforcement is necessary and then pick the appropriate fabric. The challenge is to select fabric strong enough for the intended purpose, but not heavier than is needed. Most products made with fiberglass consist of many layers of fabric. Tap Plastic carries fabrics as light as 3.7 ounce per square yard up to this 24.9 ounce material. The second factor in choosing a reinforcement is the direction of the strands of fiber. Here are 2 pieces of fabric. This piece has strands running this way and that way, as illustrated by the arrows. This piece has all the fibers running in one direction. It is called a unidirectional fabric. Here is why fiber direction matters. We have laid up this unidirectional fabric with resin. When we run the strands this way, it is incredibly strong. But if we turn the piece 90 degrees this way, it is weakened substantially because of the direction of the fibers. Now take this piece of material. Its fibers are going 0 and 90 degrees. It is strong in this direction and in this direction because of the bidirectional strands. Here we have a fabric called mat. Notice that its fibers go every direction. It provides equal strength in all directions. Therefore, it is omnidirectional. It is almost always used in conjunction with a cloth for maximum strength. One of the special characteristics of mat is its ability to conform to compound curves and complex shapes. These fibers are held together with a glue that dissolves in polyester resin. When that happens, the fibers behave like paper mache and conform to shapes that most cloth could not do. The third feature of a fabric is its weave. By that, we mean the pattern the threads are woven in. Here are 2 pieces of 9 ounce cloth. They are the same weight, same material, same fiber direction, but they are different. Here we see what is called a plane weave. If you look closely, the threads go over and under every strand. The thread direction is 0 and 90. Now compare with this fabric. It looks like the strands are going diagonally. But if you look closely, you will see that they are still going at a 0 and 90 pattern like the plane weave. But they are going over 2 strands and under 2 strands. This is called modified twill. Why is this important? The weave affects the flexibility of the fabric. If we try to conform this plane weave fabric over a compound curve, we get several wrinkles which would have to be dealt with. However, the looser weave of the modified twill allows the fibers to move more freely and conform to complex shapes. This makes modified twill a perfect choice for anyone working on curved surfaces. The fourth characteristic of fabrics is the composition of the fabric itself. TAP Plastics carries 4 fabric materials: E-glass, S-glass, carbon, and aramid, also known as Kevlar. Let's look at each. E-glass is the most widely used material for the consumer market. It is also the most economical. Fiberglass fabric is made out of microscopic strands of glass. There are hundreds of strands in every thread. This picture shows the size of a single strand compared to a human hair. The larger one is the hair. We can demonstrate that this is glass with this thread. Glass is very strong when pulled, but glass does not like to bend. So when we fold the piece like this and twist it, all the fibers break. That is why you never want to buy folded pieces of fiberglass. TAP Plastics always rolls the material on a tube and cuts it to your desired length. The second fabric material is S-glass. It too is glass, but glass that has been chemically modified to be much stronger ounce for ounce than E-glass. For the same strength, you can use less S-glass than E-glass, and thus less resin, with the result of a lighter weight and no loss in strength. S-glass comes in a 30-inch width, which is ideal for high-performance surfboards, where both lightweight and high strength are critical. The third kind of fiber is carbon or graphite. It is easily recognized by its black appearance. Carbon fiber offers extreme rigidity with minimal weight. Because of its light weight, it is used to make military and commercial aircraft, competition sailboats, wind turbines, and even high-performance bicycle frames. The fourth kind of fabric is aramid, with the common brand name of Kevlar. It has extreme impact resistance and is appropriate for locations with that need to withstand such forces. By selecting the proper weight, fiber direction, weave, and fabric composition, you can produce the best performance with the least weight. TAP Plastics has the materials you need.
TAP Plastics, the fantastic plastic best.